Okay, here's some hints for homework sheet 11. First questions, quite a lot to do here. Sketch a graph showing the roots, the y-intercept, the line of symmetry, the turning point and its nature. So let's take the roots first of all. The way we find the roots is we solve the equation equal to 0. So if you solve that equation by factorising equal to 0, that's going to give us two numbers, x equals and x equals. So that immediately is going to give us the places where it cuts the x-axis. We know it's a happy graph, so we know it has a shape like that. What are we going to do next? Well, probably the next easiest thing to find is where it crosses the y-axis. And it crosses the y-axis at this point here, the number at the end. So that's easy enough to put in. Next thing we're going to find is the line of symmetry. So what's the equation of this line here? We should know it has the equation x equals, and the number that it equals is the number which is halfway between the roots. Okay, so whatever answers you got for the first part of the question when you found the roots, if you find halfway between them, that'll tell you the equation of the symmetry. And then lastly we just need the turning point. Well, the turning point, the x coordinate is this answer here, the line of symmetry, so that goes in here. Then how do we work out the y point? We just simply put that number back into the y formula up here. So that number back into the y formula tells you the y coordinate, and then you can write down if it's a maximum turning point or a minimum turning point. Okay, so there's a lot to do in that question. Question 2 is a bit quicker. Remember, it's 5 plus 3 times that bracket and 3 times that number to be bigger than 20. Now you just go and solve it as normal. Question 3 is a Pythagoras question. We know from Pythagoras that to find the small side, it's the big side squared. Take away the other small side squared. So if you just work out what each of these are, I'll do that one for you. You can work this one out. Do a takeaway. Get your answer. X is the square root of that. Remember, if it comes out to be a third, you need to simplify. And it does. Question 4, some indices. Well, we should know that when we're given these indices that we deal with the coefficients first of all, so that's the numbers in the front here. So the first thing we're going to do is we're going to deal with 6 times 3 divided by 2. So you're going to get that answer, and then you're going to deal with the powers. And we know that when we're dealing with powers, that when you multiply, as you are in this case, you add the powers, and then when you divide, you subtract the powers. So that should tell you what your new power is up here. For the second one, root 2 times root 6 is root 12. Root 2 times root 2 is root 4. Now all I need you to do is simplify that. Question 5, the paper one. If one sheet of paper is 8 times 10 to the 5, then 500 sheets is going to be that times 500. Okay, now can we do that? We can leave that as 8 times 10 to the power 5, and then we can rewrite the 500 as 5 times 10 to the power 2. Now we can do this number times this number, like we did in the last question with the coefficients, 8 times 5, and then deal with the powers, add them together. Now the only problem when you do that is your answer, remember this first number here has got to be between 1 and 10, and it won't be, so you need to make it between 1 and 10 by altering the power up here. Question 6, remove the brackets by doing 2x minus 3 times 2x minus 3 on the left hand side, and x plus 1 times x plus 1 on the right hand side. So get this answer, tidy it all up, and you'll be left with something equal to 0. How do you solve that? We then need to bring the brackets back to get your two answers for x. So we're removing brackets, tidying up, bringing the brackets back and solving. Now question 7. 5 bits to this question. Let's look at the first part first of all. It says calculate the height of the tunnel. Now the height of the tunnel I've shown you here is h in the diagram. So if I take that over to my picture, that is that distance there. Okay, now we know from the diagram that the radius of the circle is 3. That means from the centre to any point on the edge is 3. So all these lines I'm drawing in are 3. So this line here is 3. Now let me take these lines back out to declutter the diagram. Back to what we had. Right, so because of the radius, then we know that this height here is 3. So really what the question is asking is what's this little height here? And if we can work out what that little height is, and if we add it to 3, then we're going to get the overall height. So it's 3 plus whatever that little height is. So now, extracting the triangle from the question, putting the information on it we know that the sloping side is 3 because that's a radius. We know the bottom of that triangle is 2.4 because we know the whole thing is 4.8. So if I do a little bit of work on Pythagoras here to work out what x is, if I substitute it back in there, that's going to tell me what the height of the tunnel is. For part B, calculate the size of angle AOB. So that's the size of this angle in here. Now we can't do it with the triangle as it stands. So what we need to do is we need to split the triangle in half. Work out half the angle and double it. So let me take this bit away that we don't actually need. Go back to the information that we're given in the question. We know the sloping side is 2.3. We know this side is 2.4. Now if I do a little bit of SOHCAHTOA work on that, then that's going to tell me what this angle here is. And then remember, I just need to double that to get the angle you're looking for. Now part C says you have to calculate the area of the triangle. Now you know that the formula for the area of a triangle is half the base times the height. We know the base, it's given us in the question. We also know the height of the triangle because we worked it out in part A. So that's a half of 4.8 times whatever you got from part A. That should be an easy bit of the question. Part D says we have to calculate the area of the cross section. Now the cross section is the whole front of the tunnel. So all of that. Okay? Initially you might think, how on earth do I do that? But if we break it up, we've already worked this out, haven't we? We've worked out what the triangle is. That was the last part of the question. So therefore, all I'm having to find is the area of this part of the circle, the area of a sector. Right? So if I draw that on its side, you're probably more familiar with it, like sort of Pac-Man type question. And you have the area for that is pi r squared times the angle at the centre divided by 360. What is the angle at the centre? Well, if you've been remembering what we've been doing, we know that this angle here from the first part of the question, over part B, is, I'm just going to tell you, 106. So therefore, you should be able to work out this angle. Okay, by taking it off 360, work out this angle here. You know the radius is 3, so that's pi times 3 squared times, you know the angle, divided by 360. That's going to tell you the area of the blue part. So the total area is the Pac-Man shape plus the triangle shape that you had earlier. That will give you the total area of the front. And then lastly, calculate the volume of the tunnel. Well, here's a wee picture of the tunnel in 3 dimensions. A formula that you should be familiar with is that the volume is equal to A times H. A stands for area, H stands for the height or the length, depending on how your diagram's looking. And in this case, because we are using this, it's the length that we're going to use. So the area that you got for part D goes in here, times its length, which the question tells us is 500, and that gives your answer in metres cubed. Okay, hopefully that helps.